Okay, we're looking for, what I always say, low-hanging fruit, stuff that you can do quickly. And I'd be honest with you, if this is a cold call and I looked at this over here, I'd be honest, I don't know which would be the easiest one to do. Now, certainly, I probably would go for the sum formula first, and the reason being is that, sums generally are going to work out if you see something, but I would start it. And what do you mean by starting it? I'll write this down for you. If I'll start at 0, so it's going to be 0 over 5 to the 0 plus 1 over 5 to the first power plus 2 over 5 squared plus 3 over 5 cubed. Well, you know what? I got a feel for it. But more importantly, I'm looking at this thing, and I realize the first term is going to be 0. So I'm going to rewrite the sum as n equals 1 to infinity of n over 5 to the nth power. So my claim over here, it's really the same as the original sum. Now, the next thing I would do, and this is just something that I would do, and I would recommend doing this over here, I'd write down the nth partial sum with the hope I see something simple. And by what I mean by simple is a closed formula for it, or at least a direction where I could go further by taking limits, for example. So let's take a look, and I'm going to write down Sn for you. And what's that going to be? It's going to be equal to the little n equals 1 now to big N of the little n over 5 to the little n. And what's that going to equal? I'll write this down for you. It's 1/5 plus 2 over 5 squared plus 3 over 5 cubed plus 4 over 5, 4. I'm getting kind of tired here. Plus yada, yada, yada. And then I get to the very last term, and the very last term would be the big N over 5 to the big N. Yeah, just the big N. All right. So someone says, what are you going to do now? Well, I'm still going to look at it. And what I want to do is I want to write down, because I notice there's these factors of 5 in the problem. So I'm going to just take a stab at it and say 5 times Sn. And what would I get? All right, so let's write this down. Well, 5 times the first term is just 1. Now, 5 times the second term is going to be 2 over 5. And 5 times the third term would be 3 over 5 squared. And so forth and so on. 5 times the next term would be 4 over 5 cubed. All right, I'm going to say yada, yada, yada. It gets to the end eventually. And what's that going to be? N, that's big N, and then it's going to be 5 to the n minus 1. All right? So what I'm going to do now is I'm going to take 5 Sn and subtract Sn. All right, let's take a look. And point out what I'm looking at. I'm looking at things that, that terms go well together. I'm just highlighting these terms over here. These terms, pairwise, go really nice together. All right? So what would you get? You would get 1. That's right there. And then this minus this is just 1/5. And this minus this is going to be 1 over 5 squared. And then this minus this is going to be 1 over 5 cubed. Well, I'm definitely seeing something I recognize now. This is geometric. My question is, where's it going to go? And I'm looking at it, and I'm starting to realize I'll eventually get to this term here, and is there something to take away from that? And there is, and that term would be right over here. And what would that term be? That term would be, let's see, n minus 1, right, over 5n minus 1. Now, same denominators, what do I get? Well, I get big N, I'm just doing the tops now, minus the quantity n minus 1. So what do I get over there? I would just get 1 over 5n minus 1. Now, let's not forget we have this guy here to deal with. And someone says, I wonder what that guy is. That I'm subtracting. I have nothing to pair it up with, though. All right, so minus n over 5 to the n. Now, by the way, I want to point out again, this I can definitely recognize as being geometric. So what I want to write down is, I'm going to write this down now. So Sn, all right, I'm going to do this subtraction. Whoops, sorry about that. I didn't mean to do that. I'm going to do this subtraction, and I'm going to write it down for you. So it's going to be 4Sn equals this thing over here, minus this thing. All right, let me write this down for you. 1 plus 1/5 plus 1 over 5 squared plus 1 over 5 cubed plus, oops, I didn't put the yada yada yada, did I? Dot, dot, dot. I knew about that. Sorry about that. Well, I still want Sn, don't I? And what's that going to equal to? 1/4 of this geometric. I'll write that down for you. Whoops. Just writing things down. Yada, yada, yada. Minus that big N over 4 times 5 to the n. I divided both sides by 4. Now what I'm going to do is take the limit. Limit as big N goes to infinity of Sn is actually going to be the sum. And let me tell you what the sum is. This is the sum we're looking for. All right, I'm going to let that N go towards infinity. And what's nice about that, you know, I want to figure out what the S is in the problem. I'm looking at it, it's going to be 1/4, and this is just a geometric sum. So it's going to be A1, which is 1 minus the common ratio, which is 1/5. All right, so that limit's done. Now this limit over here, I hope you realize that the bottom, that's an exponential 5 to the nth power, grows much faster than that linear top. So that's going to be 0. I'll write that down for you. Can I do that? I think so. That would be 1/4. Complex fraction multiplied by the minor LCD, that would be 5. And this would be 5 minus 1. So what do you get? 1 times 5 is 5 on top. And on bottom you get 4 times 4, which is 16. So I'm going to claim that, you know, 4 it wasn't that bad to do. We got through it. Now, could I have made a mistake? Of course. But let's take a look at the key. And I'm seeing it, 5/16. And they got the work down for me as well. All right, so I'm gonna go back to the problem set. And I got 1 down. And I'm going to do number 1 for you now. All right? I think 1 doesn't look too bad. Now, I want to point out mathematics. A lot of times when we see things that look complicated, we just simply say, okay, make a substitution, make it easier for you to deal with. And I'm going to do that substitution for you now. Now, in mathematics, we usually do what's called a U substitution. And I'm going to let U equal the argument of the function, which is x minus 1 over 2x plus 1. And now I'm going to try to solve for x. So you're going to get 2xu plus u equals x minus 1. What I do, I multiply both sides by the LCD, 2x plus 1. Now what I'm going to do is I'm going to try to get the x's on one side and the u's on the other. All right? So I'm going to say u, it's going to take steps though. U plus 1 equals x minus 2xu. Let's see how I did there. I took away 2xu from both sides and had 1. That's pretty good. Let's keep going. I'm still not there. U plus 1 equals, I'm going to pull an x out, and what do you get? You would get 1 minus 2u. Well, I'm almost there. U plus 1 over 1 minus 2u is equal to x. So someone said, what did you just accomplish there? Well, I made things a little bit simpler. And I'll tell you what I made. I know that this over here is that, and I'm looking at the x now, and so I know this, but not fully. I'm going to write this down now. What's x squared equal to? It's equal to this. So let's write this down. F of u is equal to the x squared. What's that going to be? U plus 1 over 1 minus 2u. And that's going to be squared. Okay? Now what does it say? It says find f of x. Well, you know what? I have it now. And again, I'm just going to make a substitution now. Another substitution. I'm going to say u is equal to x now. So we're finished with this one. And now I'm going to say u is equal to x. What do you get? F of x is equal to x plus 1 over 1 minus 2x, quantity squared. What else they asked me for? Find f of t. Another substitution. What's f of t? That's going to be this. T plus 1 over 1 minus 2t, quantity squared. All right, those are done. I'm going to look at the answer key and see how we did. And I'm seeing it. Now, they made a different substitute. They made a substitute t to begin with, but that's fine. So, x plus 1 over 1 minus 2x, quantity squared. All right, we got that. We did pretty good. All right, so we did 1. I did 2. Did I do 2? No, I didn't do 2 yet. Why would I say I did 2? I didn't do that. Maybe I did it before, but I don't remember doing that. Did I do 3? No, but I did 4. I didn't do 5. Wow, I'm going pretty slow, aren't I? Now, I'm going to do 3. All right, so I want to make sure you know what I'm doing. 3. I got to read it. 2 circles. Their centers are P and Q. I see a picture. It's very nice. They said a line segment MN is parallel to PQ. Well, that's not so bad. I look at that. It looks pretty good. I can see that now. And again, the line segment MN is parallel to PQ. That might be helpful, by the way. And it goes on to say that the line segment PQ is equal to 3 units. And M and N, they want to know what that is. So what I'd recommend you do is, maybe draw some things in over here. And what I'm going to do is I'm going to do this over here. And that's the radius of the circle, P. I hope you realize if that's the radius of circle P, this also has same length. All right? Now what I'm going to do is I'm going to put the radius of circle Q in. And that equals this over here. And that radius could also be drawn this way. All right? So what I want to claim over here is that, I might want to put some other lines in. And I'm going to put a series of them in. Put one here. I'm going to put one here. And these are lines that are perpendicular. Now, M and N is perpendicular to PQ. So if this is a right angle, this would be a right angle. Right? They're perpendicular to both of those lines. All right? So then the problem becomes, I hope you realize that I've got something of an idea that these triangles that I just drew, I'll point out what I mean by that. For example, I'll do that let me do it in green. That this triangle here, right, is the same as this triangle over here. And this triangle here is the same as this triangle over here. All right? What's our question here? What's M and N? I don't know. But what I do know is this. I'm kind of looking at this, and I'm seeing another triangle now. I'm seeing this triangle. So I know that they share a lot in common, by the way. Like, for example, the length of this one is the length of this one. It's the same as the length of this one. Now, the length of this one is the same as the length of this one. Right? You get the idea? Length of this one over here. Now, what do I know? And I'll tell you what I know. I know the length of this. And what is that? It's the length of this. And what's the length of that? It's actually 3 units long. So this length over here, whoops, sorry about that. This length over here is 3 units long. This is double that. Right? Because there's 2 of each of those. So if this is 3, this whole length would have to be 6. Let's look at the key. All right? And again, we use the diagram. We have parallel lines there, and we did some similar triangles. And we did okay. And the radius is certainly, in the circles, the radius of P is going to always be the same. and the radius of Q is always the same. So we saw the triangles there. So let's take a look at it. Let's look at number 3, and let's see if they've answered it with 6. Bingo. All right. So let's go back. We did 1. We did 3. I did 4. I didn't do 5. All right, we'll get back to that later. Now, what I'm going to talk about is problem number 2. Number 2 is a very, very typical problem you see on the web. I got to be honest with you, every problem you are seeing, you can definitely find on the internet. Every single problem. This is what makes, problems so difficult to give students for extra credit nowadays, because they can find any problem that you give them on the internet. All right? It's very tough to come up with a problem you haven't seen before. So I'm going to say all these problems over here over a lifetime. Maybe I collected these things. Maybe I saw it here or there. But the internet is just crawling with questions, and some of these are pretty good. And I'm going to say it's a really good question over here, but it's all over the place. It's the bug problem. What do you got over here? You're an ant. You're sitting in one corner of a cubic room. Let me draw a picture of that. And by the way, I'm not saying it's an easy question. I'm just saying, once you see how someone solves that, it becomes pretty easy to reproduce the problem. And it would sort of be a gift if this did occur in an exam and you've seen it before, because you'd be able to do it quickly. Would you be able to remember it? I think so, but maybe not. All right? So you're an ant sitting in one corner of a cubic room. Each edge is 3 meters in length. Let me outline that for you. So each edge is 3 meters. Right? Every edge of the room, it's a cubic room, is 3 meters. And what do they go on to say? It says, the bug is in one corner, and the bug can't fly, but he can walk. But he can walk along any surface he wants, ceiling, floors, walls, whatever. And his objective, by the way, is to get to the opposite corner. And I'm going to say the opposite corner is over here somewhere. All right? Now, I'll be honest with you. If I were the bug, the smart thing to do, by the way, they didn't say the smart thing. They said the thing he wants to do is get there in the shortest distance. But the smartest thing to do, I would say the path of least resistance with me, drop to the floor and then walk over there. But that's not the shortest distance. All right? But that's the simplest thing to do. Just drop to the floor. An ant could clearly do that. Going down is a lot easier than going, at least I believe so. I mean, going down should be a lot easier. I might be wrong about that, but to me it seems like I would much prefer to go down, if it were me, and then walk across the floor. Just what I do. All right, but that's not their question. Their question is take the shortest path. So I want to point out, and I want to go to the picture that this is typically what you see on the web is what they do. I want to outline what they do over here. They take the room and they just simply fold out the box, so to speak. And this is where the bug is. He's at A, but he needs to get to B. Now, if I folded out the room, it looks like this. I want to go through what these sides are, though, as I'm looking at it. So I want to go through a couple different things. This is the ceiling. All right? That's what I'm looking at, the ceiling over there. Now, I'm also going to talk about the walls. These would be the 4 walls. That's a wall. That's a wall. This is a wall. And this is the wall. I got one last thing I didn't color in yet, and that would be the floor. So let's see. I'll paint the floor, I don't know, black. This is the floor. Right? It appears that the shortest distance has nothing to do with the floor. So someone says, when you fold this thing flat, does it become obvious what the shortest path is? I hope so. All right? And the shortest path is that straight line distance between A, which means he goes across the ceiling, but not to a corner, and then he goes down the side of the wall. By the way, you could do it in 2 different ways. You could do it this way too. All right? Those are adjacent walls. So I'm going to say over there, looking at it, can I figure out the lengths of those paths? And I think I can. I'll tell you why. Pythagorean Theorem. So what I want to do is I want to draw a triangle in here for you. And by the way, they're both the same triangle. You know, this is one triangle, and this would be the other triangle. Now, what do you know about those triangles? They're both the same triangle. I got, you know, this over here. This is the distance. This would be 3. This is 3 plus 3 over here, so it's 6. Now, if I did the other one, what would that be? That would be 6. That would be 3, and it's still D. So it's going to be the shortest distance. What would you do over there? Distance squared, right? Using this right triangle, is equal to 3 squared, which is 9, plus 6 squared, which is 36. And what's D going to be equal to? I'm sorry, D squared is going to be equal to 45. So D is going to be the square root of 45. I don't mind that answer, by the way, but I want to point out it might be a good idea to simplify it, but you don't have to. So I'm going to say 9 goes into 45 5 times, so it's 3 root 5 meters, and that's what D is. All right? So I want to go back and see if I've answered the question. And the question is the ant. Yeah, they got it written down, 3 root 5s, all right, 45, all right? And again, I want to point out that this is a very typical picture. I just lifted it off the web, by the way. I did not draw that picture. So let's go back and see if I've done, you know, most of the problems. You know, 1 wasn't that bad. 2, if I kind of didn't have that picture, I might have had a tough time with that. And I'll be honest with you, I probably would have just got the wrong answer quickly. And that's not a bad thing on a competitive exam to get the wrong answer quickly. If you're taking an hour to get the wrong answer, that's a ridiculous thing. 3, we did. I did that by looking at the picture. 4, we did. It turned out to be a nice, simple geometric problem. And now I'm going to do number 5, all right? Now, I'm not going to erase it. I'm just going to go to the key, and I'll talk through it. All right, I'm going to talk through number 5 in the key. The first thing they tell me is they tell me they're integers, x, y, and z. So I know they're integers, and that really does help me a great deal, by the way, because if it was just real numbers, I'd be a much bigger struggle for me if they were just any old real numbers. So I know they're integers, and what do they say? X, y, and z are geometric. So I want to point out what that means. A geometric would mean this, that, you know, you have a term, you know, x. The next term is going to be x times some multiple. I'll write this down for you. And the next term would be x some multiple, so that would be r squared then, right? So what do I know? Looking at it, I know the first term, this is a sequence of 3, by the way, times the last term would be x squared, r squared, is really the middle term squared. So I know something about this right now. I know that x times z is going to be equal to y squared. And that's a geometric property of that. All right? Now, is that going to answer the question for me? No, it's not. And then they tell me something about this over here. They tell me the other one's arithmetic. All right? So what does that mean? Well, let's write this down. So you got 7x minus 3, right? And the next one's going to be, well, if it's arithmetic, I just add a constant multiple on. 7, and a multiple, I'm sorry, constant number, or a difference, they say. And what's the next one going to be? Well, the next one's going to be, let's see, it would be 7x minus 3 plus 2d. Now, what do I know about that? I know that if I took this term and that term, right, and let me see if I got that right. I add them together, and I divide by 2, I'd get the middle term. So let me put that down for you. So if I add the first and the last term together and divide by 2, let me write that down for you. 7x minus 3 plus 5z minus 6 and divide by 2, I'd get the middle term. And what's the middle term? It's y squared. All right? Let me see if I can do that. And what do you get? I got this over here, by the way. Maybe we'll use that later. But you're going to get 7x plus 5z, right? Make sure I'm doing this right. Minus 9 over 2 equals y squared. You know, I got a lot of things going on over here, but I've got, kind of two things, all right? So I'm going to get my eraser out and just, I don't think I need this underlined. I don't think I need to do that anymore. I don't think I need to write this down anymore. I got them written down for you. Let me just get the I don't need that circled anymore either. Here comes my problem, though. And I want to be honest, it's a bigger problem than you think. The bigger problem is, like, what integer satisfies these relationships over here? And I got to be honest with you. For me, integers are nice numbers, but they're also incredibly difficult to deal with. But I want to point out that I got 3 letters, and it certainly would be nice if I could get it down to 2 letters. And I'm going to do that now. So I'm going to write down 7. Whoops, sorry about that. I'm going to write down 7x plus 5z minus 9 over 2 is equal to y squared, and y squared is just xz. All right? So, my understanding of this is that I certainly don't like the fraction at this point, but I do know everything's got to be an integer, and there could be many choices to make that an integer. All right? So again, reading it says integers x, y, and z are members of a geometric progression, but integers blah, blah, blah are members of an arithmetic progression. Find the integers x, y, and z. Let's take a look. The way I'm going to do this, I'm just going to rewrite it. I got 7x plus 5z minus 9 equals 2xz. All right. Let's see what we're going to do over here now. I think, let me think I can do. Let me solve for one of the letters. All right, let me solve for one of those letters. I'm going to need some more room here. So let's take a look. I'm going to solve for x. Let's try to solve for x. You could solve for z too, by the way. So let me put this down. I'm going to put down, 5z minus 9. This could be a dead end, by the way. 2xz minus 7x. Well, I got the x on one side. Let me start it right. 5z minus 9, 2xz minus 7x. I'm going to factor out an x. This may not be helpful, though. And what do you get? 2z, right, minus 7. All right, I'm going to write this down now. So I'm going to write down x equals, and that's going to be 5z minus 9 over 2z minus 7. Whoa. Well, you know what? I got to do something to make this easier for me. And this is where a trick really lies into the problem. But what I want to do is I want the top to have a 2z minus 7 in it. And you may wonder why that is. I'll immediately get an integer to start working from. So I'm going to write this down for you. 2z minus 7 plus, well, let's write this down. What would you get? 2z minus 7. Let me write this down then. You'd get 3z minus 2. Nah, I don't think I want to do that either. Tell you what, because I still have that ratio with a z over a z, and I want to get rid of that. I'm going to erase this over here. And I'm going to try something completely different. All right, let me try to do this one over here. So I still want to get a multiple of 2z there. So let me write this over here. And I got to be really careful now. And I'm kind of looking at that. I got to think now. And I know x has to be an integer, right? And this is where the problem lies, getting that to be a simple analysis problem for integers. And you got to think now. And this is the problem. Like you're in a competitive exam, you don't have time to think. You could stop there and say, I give up. Now, because you could take some random z's now that are integers and see if you get an integer for x. I don't know, that's a good idea, though. I need something better than that, right? So I'm looking. Let me try something daring here. I can multiply the top by 2 and the bottom by 2. But I'm really not going to, I'll just do the top by 2. What would you get? Let's write this down really carefully, by the way. You would get, let's see, you would get, I'm sorry about that. I know my screen's a little jumpy over here. 10z minus 18. And the bottom is going to be 2 times 2z minus 7. All right, and I want to get that top to have like a 2z minus 7. I'm just hoping that there's going to be a nice cancellation in the problem somewhere to make it a lot easier for me to deal with. And you still have the 2 on the bottom and 2z minus 7. So I'm going to write down 5 times 2z minus 7. You would get, well, that's really tough, isn't it? You would get the 10z, but you got minus 35, right? You'd get minus 35. But I didn't want minus 35. What I want it minus 18. So I'd have to add something, right? You'd have to add 17. Let me see if that helps. Well, you know what? The 5 is not divisible by the 2. So that's a trouble. So I can multiply both sides by 2. You get 2x equals, let me write this down now for you, 5 2z minus 7 over 2z minus 7 plus 17 over 2z minus 7. Well, I got something that might be easier for me to look at. I got an integer 5. By the way, there's no integers that would make that trouble. And then what do I get? I get 17 over 2z minus 7. All right, I still got trouble. I'll tell you what the troubles are. I'm noticing the top, right, is 17. That's a prime number. So what do I know? I know that this must be either 1 or 17. Or minus 1 or minus 17. But let me see if I can do that for an integer. So I'm going to put down, I'll try them. I'll try 1 is 2z minus 7. And if I did that, I'll write these down for you, by the way. I'm trying to find the z. That would be 8 is 2z. So I found the z could be 4. I don't know if it works, by the way, but z could be 4. This would become an integer. And let me try the next one. I'm going to start to erase this over here. And I'm erasing this. And I'm going to say it's minus 1 now. And let me see if I can do that. I would add 7 to both sides. I would get 6 equals 2z. And what do you get over there? Z would equal 3. Again, I'm not saying they work. I'm just saying I'm looking at the 17 divided by 2z minus 7. I'm done with the 1 part now, because 17 divided by 1 is 17. That's not a problem for me. I'm going to do the next one now. Now, I'm going to say it could be 17, the bottom. I don't have many choices, by the way, and that's a good thing. Having choice sometimes is very, very difficult. And if I did that, you would get 24 equals 2z. Well, z would be 12. And these are possibilities. I'm not saying they're right. I'm just saying they're possibilities. And I'm going to do another one now. Let me erase this over here. Sorry about that. I'll make it minus 17. And what would you have there? You would get minus 10 equals 2z. And z would equal minus 5. All right? I'm kind of done with that. And someone says, what do you mean you're done with that? I don't know if it is going to produce the correct x, though. X has got to be an integer, too. So let's take a look at one at a time. Let's take a look. Let's try 4 first. So what's 4 going to give you? Well, 2 times 4 is 8. 8 minus 7 is 1. So it's 5 plus 17 is 22. So x would be 11. That's an integer. Let's try the 3 now. 2 times 3 is 6. 6 minus 7 is minus 1. That's minus 17. Minus 17 plus 5. Minus 17 plus 5 is minus 12. So I get minus 6. All right, let's keep going. Let's try the 12. And what do you get there? 2 times 12 is 24. 24 minus 7 is 17. 17 by 17 is 1. 5 plus 1 is 6, so x would be 3. Let's try the minus 5 now. That's minus 1. That gives you 4. X is 2. Now, let's not lose track of things, all right? So someone says, what do you mean losing track? I gotta go backwards and, you know what? I'm going to just go through this. I want to show you where this is written down for you. I got this one. Got this one. I got this one. And then I got 12 and 3 over here. By the way, my big concern right now is if I can do the y squared. So I don't even know what y squared is. Let's go back. And y squared is this over here. So I got to do the x times the z and see if I get a y squared. Remember, y's got to be a perfect square. So I'm going to get my little red pen out and cross things out that are clearly not possible. What I'm going to say is that if you look at this first guy here, remember, let me write this down for you again. Y squared is xc. Everything's an integer. Clearly, 4 times 11 is 44. There is no integer that squares to 44. So this one here is gone. The next one, xc is minus 18. There's no integer that will produce that. Now, the next one is 12 times 3. 12 times 3 is 36, and there is an integer that will produce that. The integer will produce that would be y equals plus or minus 6. Now, this one over here also is not a possibility. So now I got some possibilities, and let me write them down for you. And I'll just put them in black for you. And the possibilities are these over here. Let's write this down. X equals 3. Y equals 6. and z equals 12. Let's put the next one down. X equals 3, y equals minus 6, and z equals 12. All right? Now, by the way, as far as it being geometric, I'm looking at it, and it's, multiple of, for the first one, a multiple of 2. For the second one, a multiple of minus 2. So it's definitely geometric. What I want to do is I want to see if it fits the arithmetic. And so you're doing overkill over here. So 3, 6, 12, right? Or 3 minus 6, 12. And what's the arithmetic sequence going to be? Well, let's write this down. Well, let's do this one first. And what do you get? 7 times 3, that's going to be 21, minus 3 is 18. Y squared would be 36. What's the last one? 5z. Well, that's going to be 5 times 12 is 60. That would be 54. What's the common difference over here? Looks like 18. Okay, let's do this one over here. What do you get? Let's write this down. 7x minus 3. Well, it's really the same thing, 18. What's the second one? 36. What's the third one? 54. Both of these work. All right? So what was our question? Find the integers x, y, and z. We found them. So let's go back over here and make sure we did that. And it's written over here. We got the z is 12, the x is 3, and the y is plus or minus 6. So I get the answer with that. That was a tough one. It was tough for me anyway. Because maybe I'm tired or something. I hate to use that excuse, but sometimes I do get tired. I work a long day, and then I try to make videos of these problems over here. And I think we did them all. I think we did one, if you recall. We did that ant problem, if you recall. We did the circle problem, if you can recall. We did the series problem, adding it together, infinite series. And we did this one over here. So we did them all. Now, granted, some of you say, oh, you made a mistake. You did this, you did that. I don't like what you did, whatever. You can reach out to me. My name is Ron Bannon. My email address is Bannon. That's B as in boy, ANNON.US. All right. Now, when I say you can reach out to me, most people are not looking at my videos. If a lot of people are looking at my videos and are responding to me, I really can't answer your questions. I just can't do it. All right. Now, granted, I don't think it's ever going to become popular. There's one thing I know about YouTube. Stupid cat videos are far more popular than doing problems like this. They really are. And, if I were making cat videos, I would never put my email address down because I'd be getting emails from all the cat fans out there about how great my videos are. But mathematics, you really don't see much engagement in it. I'm not saying some people don't get engagement, but some people do. I haven't seen much engagement in my videos over here, including from my students, by the way. But again, please feel free to reach out if you need to. Thank you.